Welcome to 3 Inquisitive Kids. In this video, we will be learning about rational functions and doing a couple of examples with rational functions. In these couple of problems, we'll be dealing with a form of a function that looks like this. It's where you have ax plus b over x, where the constants a and b are positive. This is not just any type of rational function. It's a rational function with a slant asymptote. Some other things to know about this function is that it is an odd function, and there are some generalizations to find the maximum and minimum values for f of x when x is positive and when x is negative. So let's take a good look at this table. We see that when x is positive, on the interval from 0 to square root of b over a, it's decreasing, and it's increasing when x is negative. And the function is increasing when x is positive, and f of x is increasing starting from the square root of b over a when x is positive, and decreasing if x is negative. And there are also ways to find the minimum and maximum values. If x is positive, the only extrema would be a minimum value. So this is how you find it. And if x was negative, the maximum value for f of x would be this. And some other things to point out. The range for this type of rational function goes from negative infinity to negative 2 times the square root of ab, union with 2 times the square root of ab to positive infinity. And we have a slant asymptote. This is a line where the graph never touches it. It's y is equal to ax. So now let's get started on some problems. The first problem is to find the minimum value of this function. So first, we see that we can have an x squared plus 4 in the numerator as well as in the denominator. So we can let a be equal to the square root of x squared plus 4. So let's let a be equal to the square root of x squared plus 4. A good practice as a mathematician is that when you choose to represent an expression with one variable, it's very important to think about what can be the possible values of this new variable. If we know that x squared must be greater or equal to 0, then x squared plus 4 must be greater or equal to 4. And so the square root of x squared plus 4 must be greater or equal to 2. And this is the same thing as a. So a, we know, must be greater or equal to 2. That we have to keep in mind. So y can now be rewritten as a squared plus 1 over a, or a plus 1 over a. Now when we see this format, we can think back to what we learned earlier about rational functions with a slant asymptote. The minimum value of y would be when a is equal to 2. So when we substitute that in, we would get 2 plus 1/2, and we would get 5/2.